Thank you. So we already have big ecosystem players like Railgun, XMTP built on top of Waku. We also have Status, which is built on top of Waku. So we are, onboarding new companies and projects rapidly over the last few months. But yeah, getting started, I'm Guru. I'm the developer relations engineer for Waku. And Waku is a family of robust censorship-resistant communication protocols that can enable privacy-focused messaging for your Web3 apps. We have 6 main ethos that we are trying to stick to. The first one being privacy, second one being censorship resistance, which is going to be the topic for today, and the third one being modular, and the fourth one being adaptive to different bandwidth environments, and fifth one being securely scalable. And finally, the biggest value proposition that we think we're adding is DOS protection or rate limiting. So Waku is not just a chat protocol. A lot of people mistake Waku to be a chat protocol, but we are far more than that. We are a generalized censorship-resistant communication protocol, which can enable various privacy-preserving use cases in gaming, marketplaces, state channels, or anything that involves machine-to-machine or machine-to-human or machine-to IoT systems or any kind of communication. So why censorship infrastructure? I just wanted to add one image that can validate the need for censorship resistance. This is this co-founder of GitHub, and he lost his access to his GitHub repositories very recently. So, I mean, this is a big problem that is going to be, in the upcoming years. I think this is going to be a big problem, and the way we are trying to solve this is by building Waku network and Waku protocols. So these are the two big segments of Waku. So it's always Waku and libp2p, not Waku versus libp2p. So we are trying to add value in zones where Waku is, where libp2p is not really concerned about at this time point. So I just made a quick chart that summarizes all the values that Waku tries to add. So we have JS libp2p, and we also have a light node implementation called JS Waku, which is currently being used by various ecosystem players. And since we are using libp2p, we already have a lot of value offerings out of the box. So, things like protocol muxing, work offline, and native roaming, and all these things come out of the box for Waku. But the place where we are trying to add value is by providing a service network and a turnkey solution, and additionally an economic spam protection model that can make libp2p networks resistant to spam or DOS attacks. So I'll make sure to send this later in the group so that you can reference it. But yeah, the key facts that I would like to highlight is Lightnode uses libp2p on peer exchange and also in the discovery process. And we are focusing more on not using gateways. I think that's something that we've been researching over the years. And gossip sub is also reduced from 6 to 4 to reduce the bandwidth and make sure it is adaptable to various environments. And also, we have a capped bandwidth on the network, which is 1 message per second, and the size is 150 KB for a message. So all these are, the benchmarks that we have right now. But yeah, it depends on the community to, change it over the time. And node incentivization is currently work in progress, so we don't have an incentivization model right now. But talking about the protocols, we have a list of protocols that can be found on our documentation. But for this presentation, I just wanted to focus on the light protocols. So the first one is the light push and filter and store. So light push is basically used for sending a message into a content topic, and filter is for subscribing a message from a content topic, and store is a temporary storage for persisting messages for 30 days. So yeah, these are the key protocols that we'll be looking at. And over here in the nomenclature things, content address is as similar or exactly the same as content topic. So we have a content topic-based network, which has different topics, highly interoperable, and you can communicate between different nodes and different content topics. So yeah. And the Waku network, anyone can run an nwaku node, the name implementation of nwaku, Waku by using the Docker compose command. We also have a Grafana board that pops up once you do the Docker compose command. So everything is like pretty much bootstrapped. So this QR code will point you to the documentation. And some quick highlights about the Waku network would be the spam protection. So we are trying to implement rate limiting nullifiers. So it's a reputation-based spam protection model that we've built over the last couple of years. And scalability is also one of the key factors that we've been looking at. So we currently shard the traffic into 8 different pub/sub topics. And we also have automated sharding, which is available in our RFCs. So all these are the various key research activities going on within Waku. And we also have services for resource-restricted nodes. Like right now, we can also run an Waku node inside a Raspberry Pi. So that's the level of adaptability that we are trying to build in. And this is the RFC that particularly points to the Waku network that we are building. So this pretty much has all the network specifications and stuff. This is a quick demonstration of how fast a 2 KB message can be transferred between different nodes. This is a transmission between real machines in the world. So it's this quick for a 2 KB message, and it's just the logs on the right side. So about the developer community, this is a bit non-technical, but then we wanted to highlight it because it's going to support a lot of things, in terms of governance of libp2p and the way in which we are building an abstraction and providing value to a lot of hackers. So we sponsored 3 hackathons last year, 3 ETH global hackathons, and we had 81 project submissions, being a comparatively new project into the market, into the hackathon market. And we also have more than 1,000 developers in our Discord community. And the Discord was kicked off probably like 8 or 7 months back. So 1,000 followers in 7 months. And I would also like to spotlight a few projects that were submitted in our hackathons. So quickly going through it, first one is Block IoT, which was one of the winners of our bounties. They built an IoT system which basically communicates using Waku as the transport layer. So this is something that we wanted to see for a long time, something apart from chat. So pretty interesting. And someone also built a app called Becamos, which is basically a privacy-preserving wallet-to-wallet location sharing app. So it doesn't let your location go into centralized stakeholders like Google or Apple. So it's pretty much like permissionless location sharing. And we also have a game called Battle of Cards, a multiplayer WWE game where you can just collect cards and use them to play around. So it's also built with Waku. And finally, someone also explored the AI use case of Waku, where they made sure that the prompting process is not linked to identities. So in a centralized LLM or a centralized AI platform, it's very likely that when you search for something more critical, maybe something about your health data, it's going to be linked with your identity. So this is where Waku can be leveraged, and we can simply decouple the identities from the prompts. So someone actually built it. So we are actively providing bounties and also retroactive funding to these teams. So yeah, I think that's it for now. If you want to know more about Waku, please make sure to check out our documentation. We have research articles and documentation for developers, everything in one link. And see you in our Discord.